Okay, hello there and welcome to this course. The goal of this course is to help you incorporate the MicroProfile metrics API into your enterprise Java application. So let's start off by looking at what the MicroProfile metrics API is. To understand what the metrics API is, we need to look at what it helps or it aims to help you achieve in your applications. All deployed applications need to be monitored to ensure that they are performing to expectations. Now, this is especially critical in a cloud-native environment. For instance, you deploy your application to Amazon Web Services. You will need to gather typical metrics about the execution environment, how long it takes for a given method to execute, how many times a given method is invoked, how many times a given class is instantiated, and all of those. These are all metrics that you would want to gather about your application. Now, it's not just about the gathering of the metrics, it's also about being able to see some kind of pattern in your application, and so you can gather these metrics from your application and then get the information into monitoring dashboards like Prometheus to be able to make decisions based on the metrics that is gathered from your application. Now, the MicroProfile metrics API gives you the tools to be able to gather deep insights about the way your application is performing. The MicroProfile metrics API is different from the health check API. You might be wondering why there's a need for two monitoring APIs in the MicroProfile API. The metrics API goes further than the health check API. The health check API simply aims at helping you automate the responses to two questions that will be posed to your application. Are you ready or are you alive? So, for instance, if your application is deployed to a cluster managed by the Kubernetes cluster management system, then Kubernetes would want to know if your application is alive and if it is ready to answer requests. Now, these questions, you can have your application answer them through the health check API. So the health check API simply lets your application answer binary questions. Are you ready? Yes or no. Are you alive? Yes or no. But the metrics API goes further than that by giving you deeper insights, by giving you more statistics about how your application is performing. Now, the structure of the metrics API is such that there are three layers to the API. There is the required base metrics, there is the application metrics, and then there are vendor specific metrics. Now, the required base metrics are metrics that the API specification, the metrics API specification requires all MicroProfile runtimes to expose. These are mostly metrics about the JVM and the underlying machine that the JVM is running on. And then there is the vendor specific metrics. The vendor specific metrics, as the name implies, is metrics that is vendor specific. So a given implementation of the MicroProfile API can choose to expose certain specific vendor details. For instance, the Payara Server allows you to expose JMX MBeans as custom vendor metrics by providing a custom metrics.xml file. And then there is the application metrics. Now, the application metrics is where you come in as a developer. The application metrics is the metrics that are exposed from your application, the metrics that you use the MicroProfile metrics annotations to expose in your application. So those are filed under the application metrics layer of the metrics API. Now, exposing metrics requires that the data is exposed in a certain format. The metrics API allows the exposure of metrics data in two formats. There is the text format, the open text format, and then there's the JSON format. You can, by default, when you make a request to the metrics endpoint in your application, you have the open metrics text format, which is a simple text format that can be consumed out of the box by monitoring dashboards like Prometheus. And then there is JSON. If you set the HTTP accept as JSON, then you're going to get the data back as JSON. Now, the question you might be asking yourself is, how do you access the metrics information? You access the metrics information by accessing the /metrics path in your application. So the metrics path is actually hosted at the base of your domain. So for instance, if your domain is fullbars.com, then you can access metrics from fullbars.com/metrics. And if you want to step forward to application specific metrics, for instance, then you're going to go to fullbars.com/metrics/application. So if you want vendor/vendor, and then if you want the base, you also go to /base. So the metrics endpoint is hosted at the metrics path at the base of your domain. Now, that also means that the metrics for every single application deployed to that particular server instance, in this case Payara Server, is going to be hosted at that particular path. So that is how the metrics, the microprofile metrics, is structured. Now let's look at it in practice. How do you use metrics in your application? Essentially, you use the microprofile metrics by using or annotating your artifact you want to monitor with the requisite microprofile annotation. So let's start off with the counted annotation. You use the counted annotation if you want to keep track of how many times a given artifact is invoked. So for instance, we have annotated the getCurrencyInfo method with the @counted annotation. All we are saying is that we want to keep track of how many times this particular method is invoked. Now, the annotation takes a number of parameters, and I would like to note here that these parameters generally cuts across the entire gamut of the microprofile metrics annotations we're going to be looking at. So subsequent metrics we're going to be looking at can all take these parameters: the name, the absolute, the reusable, and all of that. So let's look at them one by one. What is the name? The name is essentially how we want to identify this particular metrics that is related to this particular method. So we can actually access this metric by going to the metrics endpoint /application. So we can simply go to, let me just put this as a comment here, say http or https. You should use https /fullbars.com/metrics/application/ then this. So let me just copy this and paste here. So this is how you can access the metric related to this particular annotation for this method. So that is what this name is for. And then the absolute here also means that the absolute, we are saying that if we set this to true, the given name is the absolute name of the metric. If it is false, then the package name of this class is going to be prepended to this particular annotation, this particular name here, and then that will become the fully qualified name for this metric. Mostly this is false by default. Then reusable is true means that we are saying whether this particular metric can be reused for other artifacts. by default it's false. Reusable means that this particular metric is going to be registered in the metrics registry and can be used for other metrics as well. Then there's a display name, the human readable name. There's the description of the metric, and then we have tags that you can use to tag the metric. So at counted is all it does, all at counted does is to expose the number of times a given artifact has been invoked. Now you can annotate a class, a constructor, or a method with the at counted annotation. So you want to keep track of how many times a given method is invoked in your application. Then you're going to need the at counted annotation to achieve that. Now you can think of the entire metrics API as a form of customizable Google Analytics for your application. If you are used to Google, or if you've used Google Analytics before, then it's something similar that the metrics API helps you incorporate into your application. So that is just about it with the at counted annotation. You want to count how many times the given annotated artifact has been invoked. You use the at counted annotation. Next up, let's look at the concurrent gauge. Now you can see that for the concurrent gauge, we simply set the name only the name for the metric without the other parameters that the metric is capable of taking. Now, what is the at concurrent gauge? The at concurrent gauge is used to gauge the concurrent invocations of the annotated artifact. So at any given time, when we ask for the concurrent gauge metric, what we get is the number of concurrent invocations of this particular artifact. When there is an invocation of this particular artifact, the concurrent gauge is going to be incremented by 1, and when the execution ends, it's going to be decremented by 1. So essentially, at a point in time, the concurrent gauge gives you how many concurrent usage of the particular artifact is in use. How many invocations, for instance, for this method, how many concurrent invocations do we have for this particular method? You get that with the at concurrent gauge. And then let's look at this one. There is the at gauge. What is the at gauge annotation? The at gauge annotation is used to gauge certain metric in your application. Now, of all the microprofile metrics construct, is the only one that you as the developer would need to return data for. So in this particular get count of countries method that we've annotated with the at gauge, we are returning a long. Now we are returning a type long here. What does it do? We are simply getting the count of countries. Now you use the at gauge to sample for information from your application. For instance, let's say you are building some form of social media app, and you want to, at a point in time, or at any given point in time, you want to be able to tell how many users have signed up to your application. You can annotate a given method with the at gauge annotation, with the at gauge annotation, and then you return the count of users, registered verified users in your application. And then anytime you make a request for the at gauge metric, then you are going to get that in return. So you use the at gauge metric to sample the value of an object. That's what you use the at gauge for. Then next up, let's look at the at metered annotation. The at metered annotation is a metric that tracks the frequency of invocations of the annotated artifact. So it tracks the mean throughput and the 1, 5, and 15 minutes exponentially weighted moving average throughput. And the default metric count, or the default metric unit, is seconds. Metric unit essentially, as we have here as none, metric unit, it means is the unit in which the metric is exposed. and this is almost available for all the metrics API construct. So admitted annotation by default takes a metric unit of seconds. So this one gives you you track the throughput of the application or the annotated artifact. Then next up is the at-timed annotation. We use the at-timed annotation to track how frequently an annotated object is invoked and also how long it took the invocations to complete. So we want to check how many times this is invoked and how long it took for each invocation to complete. So that is what the at-timed annotation will be used for. And as you can see, we passed in a number of parameters here. Over here, we are setting the unit to microseconds. So you use the at-timed annotation if you want to keep track of how many times and how long it takes a given artifact to complete. You can be used on a method, a class, or a constructor. Then next up, we can talk about injecting annotations. Now all we've looked at here, these are all annotations these are all metrics we are using through annotations. Of course, the microprofile, the entire microprofile runtime is built on the CDI runtime. So we can also have a way to inject the metrics we want. Let's look at this particular class here. This particular controller class here. We have at inject and we have an annotation at metric on a type called counter here. Now the at inject here is from the CDI and at metric here is from the metrics API. We pass in the name controller counter and we have a type called count here set to the field count. Now in this particular get currency info method here, we are exposing a metric, but this time instead of letting the runtime do it for us, we ourselves are incrementing the count. So anytime this particular method is invoked, we increment the count by 1. So in this case, we've injected the counter metric and we are using the at metric annotation to register this in the metrics registry. Now I've used the word metrics registry a number of times. You might be wondering what the metrics registry is. The metrics registry, you can think of it as a register of metrics in the application, and this register keeps track of the various metrics that have been registered or that have been used in the application. So it keeps track of all these metrics that we have, and it is from that particular registry that when we request for a metric, we get the data in return. So aside from using the metrics like this, we can also inject it this way to manually increment or manually set the specific metric that we require. All the metrics we have here that we are using as annotations are things that are metrics that you can also inject and then use in your method directly. Now we've seen the metrics at a bird's eye view level. Now let's run this particular application and then make requests to the various metrics endpoints and see it in action. So I'm going to come to my terminal and say maven clean Payara -micro and start. Okay, so the application has successfully deployed. Now let's go into my REST client here and then make some requests. Now, as I stated earlier, the metrics is exposed at the metrics path at the base of your domain. So of course this is localhost, so we have it here /metrics. So this is where all the metrics associated with applications deployed to the particular server instance, in this case Payara Micro, is going to be exposed. So for instance, if this was a full-blown Payara server that had different applications deployed that are both using the metrics and metrics API in different places, then you would have those metrics exposed here. So let's just make a GET request. Let me just remove everything. Let me delete this. So we are just making a default GET request with no specified accept header to the endpoint. So you can see there is a bunch of text returned here. Now this is the open metrics format here, which can be consumed directly by monitoring tools like Prometheus. So this is the text format. As you can see, most of these are technical metrics exposed. So this, for instance, is the base memory committed heap in bytes. So all the metrics for specific layers are exposed with the layer prepended to it. So for instance, the base metrics, because this is the only metric available, we've not made any request to any of the annotated resource endpoint here. So there is no metric to expose. So we only have the base metrics returned to us. Now remember, the base metrics refers to metrics that all the microprofile implementations must expose about the underlying infrastructure that JVM is running on. So that is what we have here. Now let's come here and then try specifying the accept header here, and let's say JSON like this. Yep. And then let's hit send. And so you can see now we have the information back in the JSON format. So you can see this particular one here, this particular base here, this particular JSON key here tells us that all the data associated with this particular JSON object is of the base metric. So this is everything we have here, the memory max heap, memory committed non-heap, and all of that. These are all the base metrics. The the system.cpu.load, this is the vendor metric. So this is being exposed by the Payara runtime. So we have the two metrics here. We don't have the third one, which is the application metric, because we've not yet made any request to any of the annotated resources here. So let's do that. Let's make a resource first to the country's resource path here. Let's just copy it from here. This is it. So Payara /. Let's copy this. We copy / like this. Copy. And then let me come here. Let me remove this for now. Let's come here and then say Payara /. Good. Now let's make a GET request. So this particular endpoint here simply returns the list of all countries and territories in the world. This particular path here, the list of all countries and territories in the world, is what is returned to us here. Let's make another request. So let's just make, okay, so now we've made 3 requests. Let's come here and then this one, currency / country here, simply takes a country and returns its currency. So let's come here. Let me just come, let's copy just so that I don't make a mistake. Copy this to this point, to copy, and then come here and paste. Then let me say Ghana, which is my country. So this is my country, Ghana, and then this is my currency. The code is GHS, and then the name is Ghanaian CD, and then this is the symbol. So let me just change this, make another request to Germany. So Germany, euro as usual. Let's make another request to Australia. Okay, so AUD, then Australian dollar, and then this is the symbol. So we've made some requests to this particular path as well. Now finally, let's make a request to countries / count. Let's come here and then change this / countries / count. Then let's go. So we have 250. So this particular resource here is returning the count of total countries and territories around the world, and according to the endpoint we're invoking is 250. Now this particular method here delegates to this controller method here. This controller method in turn delegates to the geofetch service here, and the geofetch service here makes a request to an external resource. So the information that is being displayed here, together with the countries and the currency we've looked at, are requests that are made to an external resource in the geofetch resources here. The REST endpoint is restcountries.eu. So all the information we've looked at, all the data we've gotten back, is made from this particular REST endpoint. Now let's go back to our Insomnia REST client. Now that we have some information, we've made some requests to our REST endpoint that gathers metrics. Let's make a request again to the metrics endpoint again. So this time around, you can see we have significant information here, far more than what we had initially. Let's get this as JSON and see something. JSON. Good, let's go. So you can see we have the base, then we have the application metrics. So this is all information that is displayed or that is gathered from our application. There's a lot of information here, far more than we have. Now, before we dive in here, I would like to clarify that we have far more information here than we declared in our application. Where is that information coming from? Some of this information here is coming from the controller class here. Most of these annotations here are from the MicroProfile fault tolerance API, and the fault tolerance API also exposes some metrics about itself. So some of this information here is from the fault tolerance API, but we are not interested in the fault tolerance. There is a detailed guide on the Payara website that you can download about the fault tolerance API of MicroProfile, and then you can peruse that. So let's dive into the specific metrics that we have exposed here. Let's come back here. Let's start with the simplest, which is the counted one. Now we gave it a name, so let's access it via the name. Remember, we can go to metrics / application, and then we can pass in the name. So let's do so here. Let's come here. Let me just copy this, come forward. So metrics / application / let me paste this, and then let's hit send. So you can see we have the metric for this particular annotated artifact, which is the get currency info returned to us here. So get currency info, and then get currency info method. This one, that's the full name, and then there is the metadata, the tags appended to it, and then we've made 3 requests to this particular method here. So that is what we have in return here. Now we've checked the get currency info method. Now you'd want to remember that we set the absolute to true for this particular metric here, which means that we could access, or we can access this metric directly by the name we have here. Now if we come to the timed metric, if I try accessing this directly as we have here, we will get a not found. You can see it says get country list timer metric not found. Why not found? Because we didn't set this particular metric to absolute here as we did here. We would need to access this metric by the fully qualified name. So we go through the package like this, go to the package, and then you go to the class, and then you go to the metric name, like that. So if you don't set the absolute value here, you need to access the metric by using the fully qualified name. Now let's come down here and then hit send on the application path. Let's hit send here. So we have only the application metrics returned to us. So if you come down here, the get country list timer that we just looked at, this one, get country list timer, is this particular metric, this one, get country list timer. This is it. So you can see is the package name, and then the class name, then the metric name, and these are all the data exposed for that particular metric. We have the 5-minute ratio, the count, the percentile, and all of those. So there's a lot of statistical data here that is exposed by this particular metric. Then if we come here again, there is, you can see this particular metric here, bulkhead. It's from the microprofile fault tolerance, but that's not the scope of this particular video cast, so no, we're not going to talk about that. Now there is also this one, the get country list here, get country list, this particular method here, the concurrent gauge get country list. This particular get country list annotation here is for this admitted annotation here. So we have the meter, the 5 minutes, the 1 minute, the 15 minutes, and then the mean rate here. Then the count is 3. So because we didn't specify a name or anything else for this particular annotation, we simply have it raw here. It's the package, and then the class name, and then the method name, and then we have the metric exposed here. Then if we come again to the gauge, let's look out for the gauge. You can see the gauge is here. So the gauge is 250, the counter is here, there's 3, and all of that. So there's a lot of information that the microprofile endpoint exposes for us. So this is in the JSON format. We can come here and get this back in the open text format, which can be consumed directly by the Prometheus dashboard. So instead of seeing a bunch of text, you're going to be seeing very beautiful graphs and all of that exposed in the Prometheus. All you need to do is to set Prometheus to scrape this particular endpoint here, and then you're going to have your data in beautiful visualized graphs and all of those. So this is how the microprofile metrics API works. You simply annotate artifacts you want to monitor with the annotation from the metrics endpoint, metrics API, and then the relevant and requisite metrics are going to be exposed at the metrics base path here. So most of the time you're going to be interested in the application metrics. Of course, if your application is a high performance application that requires a lot of fine tuning and all of that, you are also going to be probably interested in the base metrics to find out exactly what is going on in the underlying system. But most of the time you're going to be just fine monitoring stuff from the application metric. So this is how you can use the metrics API to gain deeper insight into your application. It's very easy to use, as you can see here. It's mostly metadata related. You just annotate your artifact with the requisite metric you want to keep track of, and then the microprofile metric runtime is going to do the heavy lifting on your behalf. This screencast has just given you a bird's eye view of the metrics API. There is a detailed guide on the Payara website that goes far deeper into the individual metrics. There are details how you can use them, how you can add them to your application, and all sorts of things we've not covered in this particular brief screencast here is available in the guide. So head on to the Payara website and download the guide. The link to the guide is going to be available in the descriptions of this particular screencast. So get to the link, download the guide, peruse it, and then you can add the microprofile metrics to your application to be able to gather real-time insights into how your application is performing. Thank you for watching.